All right, so today we're going to talk about triangle correspondence, and we're going to go back to a lot of those rigid motion rules we learned back in Unit 2. So first of all, we're going to just kind of assume in this case, in this particular picture, that triangle ABC is congruent to triangle XYZ. Now, next class, we're going to learn some ways to actually prove this is true, but today we're just going to assume it in this particular example. So the way that these triangles are named is very important. A, B, C is congruent to X, Y, Z. That means A matches up with X. B matches up with Y, and so on. So taking it back to these rigid motions, what we can kind of tell in this picture is that A maps to X through a translation. So this is a translation along vector AX. So remember that little symbol for vector, we can use that arrow. So this vector maps A to X, it maps B to Y, and it maps C to Z. And actually we can put it anywhere on these triangles, and it will map every pre-image exactly to the image. So these two triangles are congruent, and this correspondence idea means that every point on the pre-image maps to every point on the image. So how we're going to use this in our math today, what does this mean? It means that all corresponding sides, let me try writing that again. It means that all the corresponding sides and angles are congruent to each other. Sorry about my handwriting, a little messy there, but it means all corresponding sides and angles are congruent to each other. So, for example, angle A is congruent to angle X because the triangles are congruent and those sides, or I'm sorry, those angles are a rigid motion from A to X. It means, for example, AB is congruent to side XY, and so on and so forth. All right, so that's the main idea for today, and it's going to be our job to find those corresponding sides and angles. All right, so there's your definition for correspondence. So each vertex of one triangle is paired for one vertex of another triangle, and also sides of those triangles. Okay, so let's skip down to here. So 4 through 9. Let's skip 1 through 3. So we have a couple triangles. It tells us that MKL is congruent to JET. So MKL is congruent to JET. So that tells us angle L is congruent to angle T. Number 5, it tells us that MK is congruent to side JE. Now is when we have to be a little more thoughtful. This is what I want you to kind of try on your own. We know angle, for example, angle K. Angle K matches up, is congruent to angle E. So if angle K is 32 degrees, this is a really big piece of information. It tells us that angle E is 32 degrees. And we can now use our triangle sum theorem to figure out what angle T is and kind of fill in all the rest of the missing pieces. So I want you guys to pause now, fill in the rest of this, numbers 4 through 9, and then we'll regroup and talk about it. So go ahead and pause now. All right, so take a minute and see how you did. If you need to pause and look at my work, you can. But here's kind of the key to this question. All right, so I was able to figure out the missing angle here for angle T by subtracting from 180, and then angle T matches up with angle L, angle J matches up with angle M, and that's how I filled in numbers 6, 7, and 8. All right, so number 9, you can see I just wanted to write those triangles with their corresponding parts matching up. So ETJ matches up with KLM. So that's the main idea. We want to find those pairs of sides and angles that correspond, that match up. All right, for number 10, same thing. I'll let you guys try this one out on your own in just a second. For number 10, though, we got to be really careful. This says ABC. So ABC is congruent to DEF. So A matches up with D. B matches up with E. And C matches up with F. So if we think about a rigid motion that can map this triangle onto the next one, this would actually be a reflection. So we talked about how the orientation flips, right? So B matches to E, A matches to D, and C matches to F. All right, so what I want you to do, same thing, little problem solving exercise. I want you to find the values of X and Y. All right, so go ahead and pause, and then when you unpause, I'll talk you through it. All right, so there you can see my math to solve for X. We know that D matches to A. Those angles are corresponding, so it means they're congruent, so I set them equal. So I said 87 equals 5X plus 2. Those two things are congruent, and I was able to solve for X. To solve for Y, we can kind of just use this triangle right here because we don't have anything that Y matches up with. But what we do know, using our triangle sum theorem, we know that all those angles together have to add to 180. So I do 3Y plus 87 plus 42. Those all have to add up to 180. And I know we're all good at that from last class. So we can solve that out and solve for Y. Okay? So triangle correspondence. Flipping to the next page. As I've already mentioned, when figures are congruent, this means that there's a rigid motion or series of rigid motions that maps the pre-image onto the image. So as long as we can find a set of those rigid motions, the triangles are said to be congruent. So what our job is going to be, we're going to practice a lot next class. We're going to look at the picture and decide, this one's kind of set up for you, how we're moving from one triangle to the next. So as long as there's a series of rigid motions, we can determine that the triangles are congruent. So to go from triangle 1 to 2, you can see what's happening here. They set you up with a center of rotation. We are rotating, and we're not sure how many degrees, but we're rotating around point D. So we're going to be really specific next class. We'll be a little bit better with this, but for now, all we can see is that this is a rotation. Now we're sitting at triangle 2. That was the first step. From 2 to 3, you can see we have a nice line of reflection here. To go from 2 to 3, this is a flip, right? The orientation has changed. So to go from triangle 2 to triangle 3, we are reflecting over line EF. That's a line reflection. And last but not least, this is kind of what we looked at on the very first example. To go from triangle 3 to triangle 4, we can see we're following this vector. And every point is mapped along that same vector. So our last step is a translation. And I guess I should name this vector here. Let's call this vector AB. Is a translation along vector AB. So that's a pretty specific way to state how we're going from triangle 1 to triangle 4. Now, since this is a series of rigid motions, remember there's no dilations here. Nothing's getting bigger or smaller. So we know for a fact that triangle PQR, which is our first triangle, is definitely congruent to triangle XYZ. So again, if you kind of follow where P goes, point P here, rotated, and now ended up there. So there's P prime, I guess we could call it. We reflected. Now point P is there. And the last thing we did was our translation. So you can see point P ended up where point X was. So that's how we're going to determine next class those corresponding sides and corresponding angles. So we can say that angle P, or point P, corresponds and therefore is congruent to angle X. And we can do that for every pair of sides and every pair of angles. Okay? So next class, we'll get into this one together. Maybe we'll start this with our bell ringer. But we're going to really specifically state a series of rigid motions that will take triangle ABC to triangle XYZ. So I don't want you to go through this one on your own. You can start to think about it, but we're going to have a really specific series of rigid motions that will help us map triangle ABC onto triangle XYZ. Okay? And we'll fill in that important discovery next class, and then we'll practice a bunch of these, and we're going to get really good at this next time. And I think that's it. Okay? So good job, guys. Come see me if you have any questions. Do your online homework check in your note packet, and I will see you next time. Bye.